Okay everyone, so when you've opened up your model colorimetry results, I'm just going to talk you through what you've got here and what you're going to do with these results to find ultimately, this is what we want to know, the concentration of our unknown solution of aspirin, impure aspirin. What is its concentration? So what we've got here in this section, here, we've got our calibration data. What that means is we took 5 solutions, and these were 5 solutions that we had a really accurate measure of their concentration. So they would have been made up very accurately using volumetric glassware, etc. And we would have known very accurately their concentration. We would have put each of these into the colorimeter, and we would have found out what their absorption is. So we have the known absorption of each of these different concentrations of this aspirin. What we've then got is an unknown, but we're going to use what we know, the blue bit, to solve for what we don't know, which is this unknown concentration of the unknown sample. So the way we use this calibration data, we take what we know, we take our known concentrations with their known absorptions, and we're going to plot a graph of them. Just go for a scatter, unjoined. Just going to put that over here so you can see what I'm doing. Okay, so what we've created here is a plot of our known information, and it's called a calibration graph. So you will title this something like calibration graph for known concentrations of aspirin, something like that. Then what you will need to do is add the chart elements to give your axes their titles, include units where needed. I've shown here that your concentration is on the X axis along the bottom, and your absorption is what's on your Y axis. So just label those up using click on the graph, go to design, and your add chart element will be there. So I'll let you put in the axis titles, give it a nice graph title. And then a really important bit to add is the trend line, but go right down to more options. You can rewind this video and rewatch what I'm doing if you need to. So we want something linear. Hopefully you can see from this data that it is a nice linear relationship. A curve isn't appropriate. We want to display the equation of this straight line on a graph. And we've got it there. This will come in handy. So our calibration graph shows that if we know the concentrations of these solutions, we've kind of measured their absorptions in the colorimeter. And this is the relationship that arises. What we're then going to do is use this information to find out this concentration of our unknown, because the thing we do know is that this unknown absorbs at this value, 1.357. Now, absorption, I've just told you, is on this axis. So what we can do first of all is we can predict a value here. If we know that this absorbs at 1.357, we can look at, that would be about roughly there, and we can go along 1.357, what's the concentration going to be? And it's going to look like, I would say, about 0.145. So I'm going to write a prediction here. I'm going to predict that the value that this unknown solution, its concentration is going to be about that. And I've done that just by eye. I've taken what I know, the absorption, and I've found that on the absorption axis. I've read across roughly 1.357, and I've gone down to kind of by eye just do it. But there is a much more accurate way to do this. So if you think back to GCSE, this is the equation of a straight line, any straight line, y equals mx plus c. As a reminder, these are what those things mean in this equation. So x and y just mean the values that you're looking at on the x or the y axes. M is the numerical gradient of that line, and C is the numerical number at which the line would cross the y-axis. Okay, so those are all the elements of a straight line graph equation. What we're doing is we want to know the unknown solution. This is an x value. This is a value that we want to read off on the x-axis. So I've rearranged this for x, because actually we know all the other things. M and C are these numbers given in the equation, and we know the y value because we've got one here. This absorption is a y value. So we know y, we know C and M, those are in the equation. So we can solve this. So what I'm going to do is I'm just going to write this in as an equation in Excel. So whenever you do this, you always start with equals. That tells Excel that you're going to give it an equation to solve. And I'm just going to put in the values here. So I'm going to open these brackets. Yeah. And I'm going to do y minus C. So my y value is 1.357. And we're going to do minus C. In this equation, y equals m, x plus C is this number, 0.0839. And the last bit of this equation, if we look over here, is to divide those numbers by m. And m is this number, y equals m, x plus C, so 8.4844. So if I press equals, Excel is going to solve that for us. And what you'll see is that our prediction was 0.14-ish, 0.145, and the true accurate value is 0.15. So that's not bad. We've sense checked our value. So once we've got this x value, that goes in here. Concentration read from the graph was 0.15. I'm going to round it. And what we've got here is it's converted it to a percentage purity. So we've got a 93.8% pure aspirin sample. To recap, we've done this by taking some knowns and finding what the relationship for this aspirin is between concentration and absorption. And we know that it's going to be a straight line relationship. That's why this is useful. So it gives us a straight line graph. From that, we can either by eye or using its equation find out if we know this, then we can figure out this. We did it by eye to start with and got a prediction. And then we rearranged the straight line equation for x, which is the value we wanted to find out. X is the concentration. Rearranged it for x and we came out with this value. So that is how you're going to use this. And just watch this video back as many times as you need to, and you will get there. I have no doubt. All right, good luck everyone.